All right, we're kind of through the last installment for ionic bonding. Again, ionic bonds are between metals and nonmetals, where the nonmetals are accepting electrons from the metals. This one is going to be about how do we write the formulas and how do we write the names. And so, as we were taking a look and we talked about in the last video, we got to have a net charge of 0. Charges need to balance out. The positive charges or the cations or the metals, they're always listed first. The negative charges or the anions are the nonmetals, and they're always listed last. The only big change here that we're going to go with is how do we actually name these items as we're doing that. So if we take a look at, and we're going to just start out with a previous example, NaCl, all right? And we know that that was a 1-to-1 ratio because sodium had a positive 1, chlorine had a negative 1, the net was 0, and therefore the formula would simply just be NaCl. Sodium will give its 1 electron to chlorine. Its sodium drops down to the lower level, energy level filled, and chlorine jumps up to the higher energy level being filled from there. So how do we actually name this one? The metal name, which is listed first, is always going to stay just as it is. So this is simply just going to be sodium. The non-metal name is going to be second, and we are going to put the majority of its name there, but we're going to change the last couple of letters to show us that it's a part of a chemical bond. And so instead of chlorine, we're going to take off the last 3 letters, and we're going to add the IDE to turn it into, chloride. Okay? So this should be an L, and I apologize for that. So this is sodium chloride instead of just sodium chlorine. And again, the IDE ending is telling you it's a part of a chemical bond. If we wanted to take a look at our second example was magnesium and bromine. And remember, it was MgBr2. That's because magnesium had a positive 2 charge. Bromine only has a negative 1 charge, but we have 2 of those bromines, so it's really like having 2 negative charges. And again, the net answer to that is 0. 2 minus 1 minus 1 equals 0. So MgBr2 is what we can make fit together for magnesium and bromine. So again, the metal name does not change. The non-metal name starts out the same, but we are going to add to it, instead of bromine, we're going to change it to bromide. And the IDE ending just tells you that it is chemically bonded together. Okay? And for our final one, just kind of so we are all in the same group together, remember we had the more complicated one. It was Al2O3. That's because aluminum has a 3 charge plus 3. Oxygen has a negative 2 charge. And we want those numbers to fit well together, so they have to go to 6 in order for that to happen. So in theory, 2 times 3 is a positive 6. 3 times 2 is a negative 6. The net result is a 0 charge from there. From here, the metal name does not change. And oxygen's a little bit of a goofy one because we take off more letters than just the last couple. We're actually going to take off the YGEN, and we're just going to add, let me change colors here so that we can see it a little better, oxide for that. So aluminum oxide is the answer to the name for Al2O3. The opposite is true as well. We should be able to go from a formula to a name and a name back to a formula. So for this one, I'm going to say that we have potassium. We'll just go with chloride. It's one that we've used multiple times here. So potassium chloride. So we need to look at our periodic table to find out some information here. What we want to know is, where is potassium? Potassium's in family 1. The alkali metals, they all like to give up one valence electron, which means they all like to have a positive 1 charge. And we already know chlorine is a halogen. It's in family 17. It likes to take on 1, so it has a negative 1 charge. So if we look at potassium and chloride, if it is going to bond together, it has a +1 for potassium, a -1 for chlorine. That's a pretty simple net charge of 0. All we need to do is write this in a 1-to-1 ratio. So potassium is K, chloride or chlorine is Cl. So for this one, KCl is potassium chloride. And how I get that is because up here, my numbers are very easy, 1-to-1, and they cancel each other out. If I wanted to do something like, let's just say lithium, oops, that's a U, lithium, and let's go ahead and go with sulfide here. We need to go back to our periodic table just to kind of take a look. Lithium, again, is in family 1, so we know that one pretty well. Family 1 is always +1 charge. If we take a look at sulfur, sulfur's over here in 16 with oxygen, and we know that 16 likes to take on 2, so it has a -2 charge. Uh-oh, we got an issue. This is not nice and neat and easy together. We have a 1 minus 2, which leaves us with a -1, so we've got to get it to 0. And how do we do that? We really need to times it by 2 to show that 2 times 1 is really 2 minus 2 is 0. So how do I actually write that? Again, we always put our metal first, and we said that we need 2 of these to cancel out the 1, so we're going to put a subscript 2 by the Li to show that we need 2 lithium +1 charges to cancel out the 1 sulfur -2 charge. So Li2S is the appropriate way to write the formula for lithium sulfide. And we can take a look at a couple of different ones and go around and around. We'll do just one more just to make sure that we're all on the same page. And let's go ahead and go with calcium. And we're going to mix calcium with and fluorine or fluoride. So if we take a look here, calcium is in family 2. It's an alkaline earth metal. We now should know that family 2s all have a +2 charge. Fluorine is a halogen. It's with chlorine and bromine. It all has family 17. It all has a -1 charge. Again, this is not a nice, neat little fit. How do we make this work? Well, we need to really multiply fluorine by 2, because 2 plus -1, -1 gives us our net 0. So how would I write that? Metal name goes first. We only need 1 of those. Non-metal name goes second, and we said that we need 2 of those. So we're going to put the subscript 2 there. CaF2 is calcium fluoride.